So in the previous video, we have already seen some basic properties which we are going to use in our geometry classes. Now here, I'm going to discuss some more properties which are related to circles. Okay. So see, if you remember one property that I have discussed yesterday, if you see a point outside the circle, right, you can join this as tangent, okay, and then you can combine it with radii, okay, radii of the circle, then you will get a right angle triangle, okay. So this is one thing that we have learned. So the angle, we know this is 90 degrees, so this is going to be easy for you. Otherwise, if you see this point, the other way in which you can proceed is, you see this point, you can join like this, you can drop a tangent like this, you can also drop a tangent like this, okay. So the next property that we have seen is this two will be equal. Now if you combine it with the radii, so radii, if you combine, this will be 90, this will be 90, and these two are nothing but the radius, so these are equal. So what you will get is actually a kite. And if you add all the, kite is a quadrilateral, right? All the angles are, if you add all the angles, if you add, you'll get 360 degree. Out of that, this is 90 and this is 90. Okay. So these two we can find easily, right? And we have seen one question yesterday. I have given you this side as 30. So you can directly get this one as 150 because that together has to be 180. So this is 150. So we have seen that this is 210. This angle is 210 if this is 30, right? So like this you can find answers for many questions. And then when we are drawing the diagonal like this, when we are drawing the diagonal, these two are equal. So we have seen, and we have seen the question also, right? So this is what you need to do if you see one point outside the circle. See, if you see again, if you see 3 points outside the circle like this, then also you should think of joining points. You should think of making a triangle, okay? So you can basically make a triangle by joining the tangents. It will be like this. Okay, so you see 3 points outside the circle, think of a triangle. Why triangle? Because you are dropping these two tangents and these two are equal anyway. Similarly, these two are equal, right? Then these two are equal. And if you can combine it with the radii, right? Radii of the circle, then this two are going to be, obviously these are radius, right? Then you can drop like this also. So all these three are equal. The advantage is you will get the angle as 90 degree, right? That's our method, right? That's a theorem. So this angle is going to be 90 degree. So these are 90. Then this is going to be very easy for you. So this is also going to be 90. So all these are 90 degrees. Then I have told you this line, if you draw this diagonal, this is the angle bisector. So this will bisect this angle. So again, these two are equal. Like if you draw here, these two are going to be equal. Similarly, if you draw a diagonal here, these two are also equal, okay? Okay, now if you see 4 points outside the circle, what you will do? 4 points means you will think of a quadrilateral, okay? So it is basically a circle in a quadrilateral. So 4 points outside the circle, you can think something like this. Shape can be anything, okay? Okay, think of something like this. This is a quadrilateral and circle is inscribed in a quadrilateral. So what is our property or what is our rule that we have learned? This two will be equal, right? This two will be equal, right? And this two will be equal and this two will be equal. So if you mark this 1 and this as 2, this as 3 and this as 4, what you can understand is, here you are getting 1, 2 and here you are getting 3, 4. Similarly, here you are getting 1, 4 and here you are getting 2, 3. So, if this as A, B, C, D, okay, now it's going to be very simple. AB plus CD is equal to AD plus BC. Very simple, right? See, from this diagram you can understand what is AB. AB is actually 1 and 2, right? So 1 plus 2. Then what is CD? 3 and 4, right? So plus 3 plus 4, which is equal to what is AD? AD is 1 and 4. 1 plus 4. BC 2 plus 3 plus 2 plus 3. So these are actually equal. Now why it is equal? That is because of the property that we have learned. Because these two sides are equal, two tangents from the external points. This is also two tangents from the external point. This is also two tangents from the external point, two tangents from the external point. And you won't believe if I give you a question which was asked in CAT, right? See, this side was 6, this side was 5, this side was 9. Or let me put it as 7. Okay, so these three sides are given and I am asking you this side. So effectively what I am actually asking you is 6 plus 5 is equal to 7 plus what? This is the question. Answer you will get in seconds, that is 4. So what will be this side? This side will be 4. And how you got it? From the property that we have learned. I hope this is clear for all of you. So one point outside the circle, you can think of a kite or you can think of a right angle triangle, depends on the question. Okay, 3 points you can think of a triangle, okay, or a circle inscribed in a triangle. 4 points you can think of a quadrilateral, and everywhere there is a possibility of getting a kite. Now what is the advantage of getting a kite? Adjacent sides are equal. Okay, and you are combined it with radii, and radii most probably either you will know or it is going to be a common one, right? So this is going to be very easy. Now generally by using circles and lines you can get questions. So how you can combine a circle and line? These are the three ways in which you can combine, right? So either there will be two cuts, okay, like this. So this is what you call a secant. Okay, now the special case of secant is what where the secant gets its maximum length. That's what you call as the diameter. Okay, so two cuts on the circle, 2 points on the circle. Okay, then another possibility is like this. The line will go like this, just touching, right? And the third possibility is no connection. Okay, so this is the first case. This is what you call a secant. When the line cuts circle at 2 points, here line touches the circle at 1 point, you call it as tangent. And in the third case, there is no intersection, you call it as like the point of intersection is not real in the third case. See, the same thing we have discussed when we have discussed about quadratic equation, right? See, quadratic equation, if this is x-axis, this is one possibility, right? The parabola will cut the x-axis at 2 points, so you will get two solutions, right? In this case you'll get two solutions, right? In this case only touching at the x-axis, so one solution. And the third possibility like this, no real solutions, right? So this is exactly the same thing as what we are seeing here. Okay, so we will be discussing about this in detail in the coming sessions and this lecture also. Now, if you see 3 points on the circle, right, we have discussed the property. So 3 points, you can, the 2 points making a minor arc, opposite side is major arc, and another point is this. So you will get an angle like this, right? So if you combine it with the center, okay, this is 2 theta if this is theta. We have seen this property. Now, this point, let's mark it as this as A, B, C. Okay, now this point C, if you shift to your right side a bit more, what will happen? See, the same arc, I'm not changing that, and the radius is like this. So I have shifted this point to this. Okay, earlier it was here, this C I shifted to this point D. Okay, now it is D. So AB is the same. So initially it was here, right? Initially the point was here, right? This was the point. Now you shifted like this. Now you shifted like this. So this angle, which was theta, is the same here only. Okay? Same here. But if you see otherwise, just like this, if you see, okay, this both are coming from the same arc and this is the center. If this is theta, you may think twice before you mark this as theta, but actually both are one and the same. So what is this? This is actually 3 points on the circle and one on the center. So theta and 2 theta. Now why this is theta and 2 theta? Why this relation? See, another property that you have learned from that you can easily understand, right? See, this is what we have discussed, right? What you can do is you can stretch this wide little like this to this side. So what will happen? This 2 theta angle will become the diameter. So just expand that 2 theta angle so that it becomes the diameter. Then how will it look like? It will look like this. So that become this diameter, and you will have another angle, right? So 3 points on the circle, you can visualize like this also, this 3 points. But what happened, the center that now became radius. No, that now became the diameter. And we know any angle inscribed within this diameter touching the point on the circle which is going to be 90 degree. And this we know 180 only because there is a straight line. So that is the ratio, theta and 2 theta, 90 and 180. And that's how you can prove this. Now 3 points on the circle you can visualize in another way also, that we have already seen tangent secant theorem, right? See, it was like this. This is 1 point, this is another point, this is a third point. If this angle is theta, right? This angle will also be theta. Okay. Now let me give you 4 points on the circle. How will you visualize it? Like this. Okay. See, here you have an arc here. You have another arc here, right? See, in this arc, I can make angles like this, and we know these two angles will be equal, right? Why? Because both are coming from the same arc. Which one is that? This arc. So that two are equal. Now can I say these two are also equal? Yes, these two are equal because both are actually coming from this arc. Okay, so this two and this two are equal. Now another way in which you can draw this is like visualize this. You have 4 points, same 4 points I can take. Okay, now this is how the question become complex. Rather than taking this as the arc, okay, I can consider this as an arc, right? This is also an arc. Then I can draw like this angle and this angle, these two will be equal, and then these two will also be equal because this is an arc, right? Common arc, angle from the same arc. So if this is A, B, C, D and the center O, you can say this AO into DO is equal to BO into CO. Now the length based properties that we have already seen in the circle, you have a secant dropping a perpendicular from the center, this two will be equal. Okay. Similarly, if you draw on the top, if these two are equidistant, this is O, this is M, this is N. If OM equal to ON, this two will be equal, this two will be equal, and more than that, these two secants will be equal. Another property that we have seen is you draw two tangent. Okay. Now, if you combine it with the radii, okay, if you combine it with the radii, we have already seen this case a lot when we have discussed about kite, and this will be 90 degree, right? We have already seen this, right? The tangent to a circle is perpendicular to the radius at the point of contact. So any tangent if you take, okay, you take a tangent like this, if you combine it with the radii, it will be perpendicular. So the tangent to a circle will be perpendicular with the radius at the point of contact. Now another is a cyclic quadrilateral like A, B, C, D. See, A plus C is equal to 180 degree, B plus D is equal to 180 degree. The sum of either pair of opposite angles in a cyclic quadrilateral will be 180 degree. That is a property, right? So sum of the opposite angles will be 180 degree. Now, how will you proceed with the questions? You generally get length based question, then area based question. Okay. So basically we will be getting length based question which we call as one dimensional, and area based as two dimensional. And area based is going to be very easy questions that we will be discussing in detail. Okay, so length based question, see, mostly it's like you need to compare like L1 L2 is equal to L3 L4. This is the logic. Okay, so see, instead of L3 L4 they will give you the area. I give you an example so that you can understand better. See, you have a right angle triangle, okay, like this. So this is 15 and this is 20, so this is 25. Okay, so this is actual question, and they will ask you this height. So what you need to do, you need to equate. Okay, so whatever we know with which we need to equate so that you will get the height. See, we know half BH is the area, right? So base is 25, so half into 25 into height will give you the area. And you may think that by getting 3 sides I can find the area easily, right? But not during when you are taking the exam, because if you need to find area by using these 3 sides, you need to do root of s into s minus a into s minus b into s minus c, and that is going to take a lot of time. That's not worth, okay? Using that method is not worth during exam. So here the alternate method will be like this. So this is the right angle triangle, right? So how can you equate? You can consider this as base, this 20 and this 15 as height, okay? So then half into 20 into 15 is equal to, you can equate like this, 25 as the base and height as this, right? So half into 25 into h. Then only one unknown. You equate this, you'll get the answer faster. You'll get it as 12. Now, even this question looks difficult, but still, when we have discussed about the method, this is going to be very, very easy for you, right? Now, even this question, now I can make it difficult by combining it with a circle. See, how can I make this question? Let me take 2 circles, okay? And the base, I take 2 midpoints, join, and I make this length as 25, okay? So I give you the radius of this circle as 20. So this is the radius, and this circle radius is 15. This circle radius is 15. So if you extend this, this is nothing but the radius itself, right? This is nothing but the radius itself, and this is nothing but the radius itself. So this is 15 and this is 20, right? And what I can ask you is, I can ask you this common chord, this total length. So effectively, in the previous question, what you have got is 20, 15, and this height you got as 12. Now what is asked? This extended, basically this is twice. Now just that triangle is just flipped over. So will there be any change in the height? The same height will come here also. So 12 plus 12, which is equal to 24. 24 is the answer here. So you can get this 12 faster, then you need to take twice of it, because these two are same only. Why? Because the base is same, this is same, this is same. Both are actually similar triangles or congruent triangles. Now what do you mean by similar triangle and congruent triangle? See if I am giving you like this is equilateral triangle, okay? 10, 10, 10. Just imagine the sides 10, 10, 10. Then this is also 10, 10, 10. These two are congruent triangle, okay? But if I am giving you another equilateral triangle, this is 60, all the angles are 60, this is 20, this is 20, this is 20. So in this case, this is similar triangle. See, congruent triangle means the length and the angle should be equal in all cases. Everything should be equal. It's like identical twins. You take 200 rupee notes, both are same, right? Exactly same. You take 50 rupee note, 2 notes, both are exactly same. So that's what you call as congruency. Congruency means everything should be same. Angle as well as the length should be same. But when it comes to similarity, it's like, see, let me give you a very simple case. Okay, so if you take this ABC, that's a big triangle, and also if you take CDE, so ABC triangle and CDE triangle, both are similar. The reason is this angle and this angle is same, this angle and this angle is same, and this is a common angle, right? So angles are same but length are different, so we call it a similar triangle. In the same way, if you take from here, if you take this CDE and DFG, okay, DFG, both are similar triangle. The reason is this is a common point, right? And this angle is same, this angle and this angle is same. So that's a similar triangle. Since the length is not same, we can't call it as congruent triangle, but these are similar triangle. Now another way in which you can get the question is, we will be discussing the actual questions, but I am just discussing the patterns that you are actually getting, so that it will be easy for you in the future session, right? See, you take a triangle like this, okay? So a semicircle is inscribed like this, semicircle, and I give you the radius. Okay, this is x, this is y, this is z. So 3 sides are given. So imagine 3 sides are given, and I will ask you to find the radius. Now how will you find? You see, the moment you see xy z, three sides are given, means it's equal to area is given, right? But the problem is you need to use the formula root of s into s minus a into s minus b into s minus c. So that's going to be very difficult. Rather, what we can do is we can cut the diagram, or we can just draw a line like this. That is also r, right? This is also r. Now if you drop a perpendicular here, what is your answer is actually half into x into r is equal to half into y into r. Then x is known, y is known, r is common, so you can find r easily just by equating. So what you have done, you just cut the diagram like this. Now this is not a simple question. This is going to be a very difficult question if it comes in CAT, and if you write in words, I can make very difficult question based on the same concept. So I hope these concepts are clear for you. Now in the next session onwards, we will be starting with the questions. So I'll take all the previous year questions and we will discuss in detail about the way you solve it, and at that time also we will revise these properties that we have learned, so that you will get a better understanding.